All right. Welcome to our Yebo Tutor YouTube channel. So, if you haven't subscribed to our channel, please don't forget to do so that when we upload new content, you will be notified. So, today we're starting our discussion on Newtonian mechanics. So, we'll be taking or attempting this uh, question 2 of November 2018, grade 12. So they are saying here, a block of mass 8 kg is placed on a rough horizontal surface. So they are talking about a rough horizontal surface. So what does that mean? What does that tell us? That means there is a friction. So the object which is in contact with that surface will experience a frictional force. So if the surface was smooth, therefore the object in contact with that surface would not experience any friction because the surface will be smooth. But in this case, the surface is rough, therefore the object in contact with the surface will experience a frictional force. All right. So the 8 kg block, which is connected to a 2 kg block by means of a light inextensible string passing over a light frictionless pulley, starts sliding from point A as shown below. So they are talking again about inextensible string. So those are the keywords we need to highlight. What does inextensible string mean? This simply means that the tension on 8 kg block will be equal to the tension on the 2 kg block. So once the string is inextensible, so that simply means the tension in the string remains constant throughout. So before we attempt to answer any question, so let's draw free body diagrams for each object or for each body respectively. So let's start by 2 kg block. So 2 kg block, which is hanging in space, will have a tension which is pulling upward. This tension is pulling this 2 kg block upward, and we are going to have weight which is pulling the 2 kg block downward. And in this case, there will be no normal force. Why? There is no normal force. Because we define normal force by a force which is exerted by the surface. We define normal force by the force which is exerted by the surface to the object, where the object is in contact with the surface. So here, there is no surface which is in contact with 2 kg block. Therefore, 2 kg block will not experience a normal force. And this normal force must be perpendicular to the surface which is in contact with the object. All right. So those are the only two forces that are acting on 2 kg block. And why are we having a weight? Why 2 kg block is experiencing a weight? 2 kg is experiencing a weight force which is pulling it downward because it is in space or in gravitational field. Therefore, any mass which is in gravitational field will experience a weight force. I hope that is clear. All right. So let's draw now all the forces which are acting on the 8 kg block. So 8 kg block is in contact with the surface, therefore will experience a normal force. So we have a normal force. Then it is in gravitational field, therefore we'll have a weight force which is always directed downward. Then other force, because this object is resting in the surface which is rough, therefore we'll have a frictional force which is in the left direction. Then finally we are going to have a tension which is applied at an angle with the horizontal. Let's say that angle is theta. Okay, let me try to change the font so that I can draw my angle so that it can be neat. All right, we have that. So what I'm going to do, I'm going to choose this direction to the left as negative because the friction tend to oppose the motion of the system. Then I'm going to choose this direction to the right as positive. Then again, the weight is pulling the object downward. Therefore, I shall choose this direction as positive, then this direction as negative, because the tension is going to oppose the motion of the body or of this 2 kg block. I hope that is clear. Okay, so what we need to do now is to rewrite this force over here, the tension. So once a force is applied at an angle with the horizontal, we resolve that force into two components. Okay, so what I'm going to do here, I'm going to redraw this free body diagram for 8 kg block, but now I shall replace the tension with its component. So we have this force, the frictional force, which is acting to the left, then the normal force, which is acting upward, then we have the weight force, which is acting downward. So what I'm going to do now, I'm going to, instead of writing the tension, I'm going to write its component. So I'm going to have the horizontal component, which will act towards the positive x direction, and the vertical component, which will act towards the vertical positive direction. So this t of y over here and this t of x over here, those are the components of the tension which was applied at an angle that direction. Sorry. Okay, so this is tx, or let me rather put the label over here. So this is tx, this is ty, this is the normal force. So we had this force, the tension, which was applied at an angle. So what I'm going to do here, I'm going to move this force over here, this tension. We have theta over here. So I'm going to move this force over here, and I'm going to explain why I'm doing that. So let me increase the magnitude of this vector. So I'm going to put this force over here. Okay, let me use the different color and wrap this one. So yeah, and I'm going to wrap off this one. So before I even wrap it, so I'm going to remove this force and put it here. Why can I do that? Because I haven't changed the direction and magnitude. I simply change the position. So this vector is still the same as this vector. So because the direction is still the same and the magnitude is still the same, so now I can finally wrap it off over here. So here we have T, oh no, I'm sorry. So let me decrease the font. So we have T ty. Then let me rub this guy over here and put it here. Okay. So we have the tension as the hypotenuse. We have this ty over here. Okay, let me again rub this guy over here and put it over here. So we have tx, ty, and t. So now we have formed a closed triangle, and we know, all right. So we formed a closed triangle, and there will be 90 degrees. We have formed a closed right-angled triangle. Why 90 degrees? Because this force is always perpendicular. T of y is always perpendicular to t of x. Because normal force and this ty were normal force, this normal force over here and this ty were perpendicular before we changed the position of this vector, which was original over here. It was perpendicular to the t of x. That is why now we're going to form a closed triangle. So now once we have a right-angled triangle, now we can apply trigonometry. So I'm going to play around with trig ratios and see what I'm going to get. So what I'm going to do, I will just redraw this triangle in the next slides. So okay, so we have t of y, we have tx, and we have t, then we have theta. So if we play around our trig ratios with our trig ratios, so let's take sine of theta and see what we are going to get. So if we take sine of theta will be the side which is opposite to theta, therefore will be this side. It's going to be tx over the tension. Therefore, if we cross multiply, we're going to get tx is equal to t sine theta. Then if we play around with cos theta, cos of theta will be the side which is adjacent to our theta. Therefore, it will be tx over our hypotenuse, which is equal to t. Then if we cross multiply, we're going to get t of x, or tx is equal to t cosine of theta. Okay, so we're done with our free body diagrams. So we are going to use now this free body diagram, the letter, this one we draw last. So this one with its resolved component, because we are going to need these components when we quantify acceleration and other dynamic variables. So what happens here is that this quantity over here, t of x, we are going to use it when we calculate acceleration, because it is the force, or it is the only component that is producing the acceleration. So this one over here, it's in the y direction, but the acceleration will be in this direction. So when we calculate the acceleration, we're going to consider only the forces which are in the x direction. Therefore, we're going to consider tx and friction, those two guys over here, this friction and this tx. Then if we want to calculate weight, maybe normal force, we're only going to consider the forces which are acting on this direction, on the y direction. Therefore, we're only going to consider normal force, weight, and t of y. But now we know that the acceleration, or the object or the system, is moving from left to right. Or rather, the 8 kg block is moving from left to right. Therefore, we're only going to consider friction and t of x when we quantify our acceleration, if we are required to do so. Okay, so let's see the questions. So question 2.1, state Newton's second law in words. So what does Newton's second law state? So Newton's second law states that if you have a non-resultant force, and this non-zero resultant force act on an object. Therefore, the object will accelerate in the direction of this resultant force, with this resultant force directly proportional to the acceleration of the object and inversely proportional to the mass of the object. So I'm just going to express this law mathematically. So mathematically, this is Newton's second law. So F net is equal to ma, and F net is directly proportional to the acceleration, and the same F net is inversely proportional to the mass. So that's how you express Newton's second law mathematically. All right, so the next question. So they are saying we must draw a labeled free body diagram for the 8 kg block mass for 4 marks. We already draw the free body diagram on the slides, on the previous slides. So over here or over here, you can choose any, but I'm just going to draw it again. So 8 kg block, we have normal force, we have weight, we have frictional force, then we have the force, the tension force, which is acting at an angle 1, 2, 3, 4. So each force, there is 1 mark for each force. All right, so 2.4. So they are saying as the 8 kg block, 2.3, when the 8 kg block reaches point B. Where is point B? Over here. So when the 8 kg block reaches point B, the angle between the string and the horizontal is 15 degrees, and the acceleration of the system is 1.32 meters per second squared. Then they are saying in 2.3.1, 2.3.1, why, give a reason why the system is not in equilibrium. So to answer this question, you must first understand the term equilibrium, or like when the system is in equilibrium. So the system is in equilibrium if the velocity of the system is constant. So the velocity should be constant for the system to be in equilibrium. Secondly, or the system should be static. So if now the velocity is constant, then the forces will be balanced. Forces will be balanced. So if the forces are balanced, therefore the velocity will be constant, and therefore there will be no acceleration. All right. So forces are balanced, therefore the net force is 0. Therefore, if the net force is 0, there is no acceleration. Therefore, if there is no acceleration, therefore that implies the velocity must be constant, because remember, we define the acceleration as the rate of change of velocity. So if the velocity is constant, that simply implies that there is no acceleration, or the system is static. That means all the objects are stationary. Therefore, those are the only conditions our system can be in equilibrium. So here we are being told that the object reached point B, and when it reached point B, it had an acceleration of 1.32 meters per second squared, which means that the system is not in equilibrium. because there is acceleration. So that's how you answer that question, because the system has an acceleration. Thus, therefore, it is not in equilibrium. 2.3.2. Use the 2 kg mass to calculate the tension in the string. So they are saying we must use this 2 kg block. So we already draw the free body diagram for the 2 kg block. So we said we have the tension, which is opposing the motion of the object. So now we're going to apply Newton's second law. We're going to say F net is equal to ma. But F net is simply equal to the weight, which is opposed by the tension. This is equal to ma. So the weight is pulling the object downward in the direction of the motion, and the tension is opposing the motion. So this is our F net, weight minus tension, is equal to ma. Now we define weight by the product of the mass and gravitational constant minus tension. This is equal to ma. So now we can substitute by our mass. So our mass is 2 kg times 9,8, the gravitational constant, minus the tension. This is equal to, again, mass times the acceleration, which is 1.32. Now, what is 2 times 9,8? 2 times 9,8 will be 19.6. 19.6 minus tension. This is equal to 2 times 1,32, which is 2,64. 2,64. So if now we want the tension, we can transpose it to this side. Then when it cross the equal sign, it's going to be positive. Then we're going to take 2,64 to this side. Therefore, when it reach the opposite, the other side of the equal sign, it's going to be negative. So we're going to get tension is equal to 19,6 minus 2,64, which is equal to 19,6 minus 2,64 is equal to 16,96. 16,96 newtons to the right, because the tension, no, downward in this case, because the tension, this is the tension for the 2 kg block, and we know this tension will be the same as the tension on the 8 kg block, which is applied 15 degrees with respect to the horizontal. All right, then 2.3.3. 2.3.3. Calculate the kinetic frictional force between the 8 kg block and the horizontal surface. Again, we're going to apply Newton's second law. F net is equal to ma. Then now we need to consider all the forces which are in the direction of the motion. So we have Tx minus friction equal to ma, according to the free body diagram, which we draw on the previous slides here, or rather here. So we have this friction over here, which is opposing the motion, this friction. Okay, let me use different color. We have this friction over here and this Tx over here. So those are the two forces which are in this direction, in the x direction, and those are the forces which are affecting the motion of the system for the 8 kg block. So this one is the one, okay, is producing the acceleration, and this one is opposing, is in the direction of the motion, and this one is opposing the motion. That is why it is negative. But earlier on, we quantified this tx to be t cos of theta minus friction. This is equal to ma. But the tension we have calculated to be 16,96. So I'm going to substitute in the place of it 16,96, because our angle is 15 degrees, our theta is 15 degrees, minus the frictional force. This is equal to 8, our mass, times acceleration, which is 1,32, because acceleration 8 kg will have the same acceleration as the 2 kg, because this is the same system. Therefore, both objects will experience the same acceleration. All right. So what is 16,96 cosine of 15 degrees? This is 16,38 minus frictional force is equal to 8 times 1,32, which is 10,56. Therefore, if I want this fraction, I'm just going to isolate it, or I'll just transpose it to this side, and it will be positive. Then I'm going to take this quantity to this side, and it's going to be negative. Then I will have 16,38 minus 10,56 is equal to the frictional force. Therefore, frictional force will be equal to 16,96 cosine of 15 degrees minus 10,56. All right. I'm going to use this quantity over here, not this 16,38, so that I don't lose the value of my answer. So the final answer that I'm getting, it's 5,82. 5, okay, let me change the color. It's 5,82 newtons. 5,82 newtons to the left, because we know the friction is opposing the motion. So this the t of x, or the x component of the tension, was in the was to the right. Therefore, the friction should be pulling the object to the left, because it is the force which tend to oppose the motion of the object. All right. So we're done with the kinetic friction. We calculated it to be 5,82. So 2.4. As the 8 kg block moves from B to C, the kinetic frictional force between the 8 kg block and the horizontal surface is not constant. Give a reason for this statement. All right. Okay. So before we try to attempt this question, okay, if we move this 8 kg block, before we move it from B to C, so let's assume we move this 8 kg block far away from point A towards the left, or infinitely away from the left, to the left, sorry. So if we're doing that, therefore this tension over here will be almost, or will be parallel to the table. In other words, the angle between the force and the surface on which our object is in contact with will be 0, or will be 180. Therefore, there will be no vertical component. But now what happens if we bring this object very close to the pulley? So this angle over here will increase as we move this object over here. So if this angle is increasing, Therefore, the vertical component will also increase. So what is the question? So they are saying here the kinetic frictional force between the 8 kg block and the horizontal surface, it is not constant. So, okay. So now let's try to answer this question, 2.4. Okay. So we define the frictional force, kinetic frictional force, by the product of the coefficient of kinetic friction times normal force. And we know if we don't change the surface, therefore this quantity over here, the coefficient of kinetic friction will remain constant. Therefore, if there is a change in friction, therefore there must be a change in the normal force. All right. So now if this friction is changing when we bring the object close to the pulley, that means there's a change in normal force. Remember, I said earlier when I was constructing this free body diagram, I said this object of this force over here, this T of Y, is affecting the normal force. So, and also this weight, or rather, to make things more simple, let me write down what I'm talking about. So I'm just going to consider all the forces which are acting in the Y direction for the 8 kg block. So we have normal force, we have weight, and then we have T of Y, the Y component of the tension. So those are the forces which are acting on the Y direction, negative and positive Y direction. So, and we know in this direction there is no acceleration, therefore F net will be equal to ma equal to 0, because acceleration is 0, therefore mass times 0 will be 0. Then what are the forces that are acting on this direction? So normal force and T of Y acting in the positive x direction. Normal force plus T of Y acting in the positive direction. But those two forces are opposed by the weight, therefore, and when we combine them, we get 0 because there is no acceleration. So if we want to isolate the normal force, or if we want to make the normal force the subject of the formula, therefore we're going to get normal force is equal to, so we're going to take weight to this side and it's going to be positive, then we're going to have weight minus T of Y. Therefore, if we change this quantity, therefore this quantity will also change. I hope that is clear. That is why now, if we change the angle between the tension and the horizontal, we are automatically changing this quantity over here. Therefore, if we change this quantity will change. Therefore, if this quantity changes, therefore this quantity over here will also change, because it is direct proportional to the normal force. So how do we answer this question? So the friction will not be constant because the vertical component of the tension will keep on changing. So that's how we answer this question. 2.4, let me use the red color. 2.4, it's because vertical component, or rather Ty will keep Ty will keep on changing. I'm sorry for that. All right. So 2.5. So the horizontal surface on which the 8 kg block is moving is replaced by another horizontal surface made from different material. So remember, so earlier they said the surface is rough. Therefore, once the surface is rough, therefore automatically we have a friction. Now, let's assume that we replace now this surface which is rough with a smooth surface. So what will happen to the friction? Therefore, since now the surface is smooth, therefore there will be no friction. In other words, this confirms that the frictional force is the property of the surface, or in other words, the frictional force depends on the nature of the surface. So to answer this question now, will the kinetic friction calculated in question 2.3.3 above change? Choose from yes or no. Yes, it will change. Why? Give a reason for your answer. Because friction depend on the nature of the surface. The object is in contact with. Yeah. So that was all from my side. Thank you so much.